When two inductors are close enough, they should not be treated as isolated pieces anymore. A changing current in one winding can create a changing magnetic flux that links the other winding. That cross-coupling is mutual inductance. It is the bridge between ordinary inductors and the ideal transformer. If current in winding 1 changes, the magnetic flux around it changes as well. Part of that changing flux can link winding 2, and winding 2 then sees an induced voltage. The better the shared flux linkage, the larger the mutual inductance M. So mutual inductance is really a measure of how strongly one winding can impress itself on the other. The dots tell us the sign of that induced voltage. If current enters the dotted terminal of one winding, the induced voltage makes the dotted terminal of the other winding positive. If the reference current leaves the dotted end, the sign flips. The dots do not tell magnitude, they tell polarity consistency. An ideal transformer is the cleanest version of this coupling idea. All useful flux links both windings, and we ignore loss. The voltage ratio follows the turns ratio. V1 over V2 equals N1 over N2. More turns on the secondary means a larger secondary voltage. Fewer turns means a smaller one. Current scales in the opposite direction. I1 over I2 equals N2 over N1. So a step-up voltage transformer is also a step-down current transformer. In the ideal case, input power equals output power, which is why the voltage and current ratios invert each other. This is why transformers are so useful in circuit analysis. A load connected to the secondary can be reflected to the primary as an equivalent impedance. Z in equals the turns ratio squared times Z load, or N1 over N2 all squared times Z load. The transformer changes how the source experiences the load. Mutual inductance explains how one winding affects another. Dot convention fixes the sign, and the ideal transformer turns that coupling into clean voltage, current, and impedance ratios. In the next lesson, we move to instantaneous and average power.